All right. So again, all right, so we'll begin. So unit test review today. We'll continue next class. Practice any problem that we don't touch today. And then next Monday, your test. Also, there was an add-on activity. So for anybody who did not do well on a Unit 1 test, you either got a message in SIS stating you may need to complete the add-on activities, or you needed to complete your add-on activities. Have another week to do it. Not sure where it is. The add-on activity is located in Schoology. Now, again, you can print it up on your own, do the work. It's a Google slide. You can answer the questions on the Google slide, turn it in, or write the problems on a separate piece of paper. Give me your work. I will accept it, and you will get some points back from your test. And for some of you, you really need to get that done if you want to, along with pass this test in order to pass for the quarter. I'm telling you right now, there's going to be phone calls going home. There's going to be progress reports going home as well. And some of you may not be a good result. All right, let's keep going. Okay, at this point, let's put all phones away. And we need to get going. That includes you. Let's hide that phone. Come on. Well, let's go. Okay. Again, test review. You guys. It's 10:18. First up, angle relationships. So, alternate exteriors. Inside, outside. Oh, no. It's not inside or outside. It's outside. Inside. Outside. Okay, so alternate interior. Alternate exterior, I'm sorry. Are we talking about the angles inside or outside? Exterior. Outside. It's outside. Now, alternate. Are we talking the same side of this transversal or the opposite side of the transversal? Opposite. Opposite and outside. All right. So, how about somebody volunteer? Pick at least one angle that's outside the parallel lines. Okay, 7. Angle 7 is right here. What angle, along with angle 7, would be considered alternate exterior? Is it 2, 1, or 8? Okay, in this case, I said that wrong. Let me rephrase. Given angle 7, which angle would match up best with angle 7 as an alternate exterior angle? So which angle is also outside but the opposite of angle 7? It's 1. Opposite of this line right here. You have to be opposite this line. The opposite of that line. So 2 is on the same side as 7. So that's why 2 and 7 wouldn't work. So, and then 7 and 8, even though they're outside, but they're not on the alternate side. Like, so it's 1 and 7. So 7 and 1. That's one example. also, they're gonna, so 2 and 8 are also 8, 2, also. Now, the other thing we have to remember, if the two angles are alternate exterior, what's the relationship between those two angles? What would be the relationship measurement-wise between angle 7 and 1 or angle 2 and 8? What would be the relationship? Not vertical, not necessarily. Not a bad guess though. Measurement-wise, you're not far off though. So we had, remember the activity that we had where we either had to figure out if the two angles added up to 180 or if the two angles were congruent? It's going to be one of those two situations. Would they add up to 180 or are they congruent? Say again? They're going to be congruent. In this case, since these guys are parallel, they're going to be congruent. That's another connection we need to make. Because if we don't make that connection, especially for some of these future problems, it's going to be a long, long school year. Not test, school year. All right, questions on this one? So, first part, we're definitely going to talk about the first six problems we definitely have to talk about. Because if you don't understand the angle relationships, you're gonna have a hard time this test. All right. Let's go to number 2. Okay, alternate interior. Is opposite inside. Again, out, in, out. All right. Somebody pick an angle that's inside the two parallel lines. Pick any one of those 4 angles. Pick any one of them. Pick any one of the 4 angles inside between the 2 parallel lines. Who could pick? Okay, that's a good start. So angle 6. Now, which other angle is opposite of this transversal line? It's going to be 4. Four would be the one. What other pair would work besides 3 and 5? Three and 5, that's right. Since they worked, now, what's their relationship? Add up to 180, or they congruent? Congruent is correct. Questions? All right. So once we're ready, we're going to the next page. Okay. Notes and recording will be posted You have all the notes. You also have a recording. Both will be posted in Schoology. Now, this part is consecutive interior angles. I'm going to stay on the inside. Now, consecutive. Are they going to be on the opposite side or the same side? Same side. They both have to be inside and on the same side. So we're looking somewhere in here. So, don't worry about outside. So, somebody pick an angle that's inside the two parallel lines. Pick any one of them. Who can tell us? Pick any one of them. All right, 3 and 6. That's going to work in this case. 3 and 6 are going to be. So then what else also works besides 3 and 6? 4 and 5. Inside, same side. Now, unlike the two other ones, what's their relationship? What's that? Add up to 180, yeah. In another word, add up to 180, which means it's supplementary. It's very important going forward. Add up to 180, supplementary. Because again, we need to, especially this year and going forward, if you see a word, you're not sure what it means, like on a test, well, actually before the test, ask. There might be words that we haven't seen before. We need to make connections. Like supplementary, add up to 180. Complementary. Now, if the two angles are complementary, just throw in a side question. What's the sum of the two angles if they're complementary? 90, very good. We're going to probably deal with more 180, but you could be dealing with 90s down the road again. All right. Questions on this problem? Now, the next three are going to be a little different because it's only going to be one period that works. Vertical. Vertical angles. Now, they're not necessarily inside or outside, but vertical angles directly across. So that's the key. You see vertical angles directly across. So to look at our 4 examples. Well, let's first look at 3 and 7. Are 3 and 7 directly across from each other? So look at angle number 3. Is angle number 3 directly across from angle number 7? Are those across? No. So it's not choice A. Because 3 and 7 are corresponding. What about 2 and 8? There's 2, there's 8. What type of angles do we have there? alternate exterior, so that's not going to work. What about 6 and 8? Would 6 and 8 work? There's 6, there's 8. Would 6 and 8 be an example of verticals? Tight. This is your winner. There's your verticals. And 1 and 7 are just like 2 and 8 alternate exteriors. So yeah, you're it. Oops, that's C. C. Choice C would be that one. Now, vertical angles, are they congruent or add up to 180? Who remembers? Vertical angles, add up to 180 or are they congruent? They are congruent, yes. That's another thing. All right, questions? Okay. Linear pair. A linear pair, supplementary. So right away, linear pair, they're supplementary. That means they add up to how many degrees? 180. Now, the other thing, if it's a linear pair, they also have to share a side. Let's look at our possible options. Would 3 and 5 work? Look where 3 is and look where 5 is. Would 3 and 5 work? No, they're not going to work. Well, those are alternate interiors. What about 2 and 4? Would 2 and 4 work? Why not? Yeah, exactly. They're verticals. 2 and 4 are not going to work because they're vertical. What about 6 and 8? Would 6 and 8 work? Basically, they're the same thing. They're also vertical. What about 1 and 4? 1 and 4 will work. Because they add up to 180, share side. So 1 and 4 would work. Questions? How are we doing, everybody? Anybody have any questions up to this point? Again, you have to know these angle connections, these relationships. Because when we start doing these other problems later on today, along with Thursday, you don't get those angle relationships. It's going to be a tough time on the test. But if you understand these, you will do well. All right. Last one. Corresponding angles. Which option would be the corresponding angle? Who could tell us? Remember, the corresponding angle is the same spot. Same spot of intersection. Well, would 3 and 6 work? Would they be considered corresponding angles 3 and 6? No. They're not. That's consecutive interior. And I'm just going to abbreviate. What about 2 and 4? Would 2 and 4 work? No. They're vertical. What about 4 and 8? Would 4 and 8 work?
Yeah.
There you go. Boom, boom. This works. And then 1 and 8 would not work at all. That's, don't even bother. So it's choice C. Now, corresponding angles. Are they adding up to 180 or are they congruent? Add up to 180 or congruent? Who could tell us? Yes, congruent. Want that in there too? Okay, questions? All right. Now, in starting with the next few problems, we're not going to do them all. We may do one and skip. One, skip. One, skip. And once we skip, we're going to look at them again next time. All right. This one, angle 7, so problem 7A, we're going to do in class. 7B, though, we're going to look at again on Thursday because 7A and 7B are basically the same thing. I don't want us to look at the same thing twice. I want us to look at a little bit of everything today, a little bit of everything next time. Understand where we're going with this? All right. So, we have this line right here. It's cutting across 2 parallel lines. And sometimes they're not mentioned, but anytime you see a line like this, an arrow like that, or it might be a double arrow, that's going to indicate which pair of lines are parallel to each other. That's also important. Now, they told us the first angle here is 53 degrees. So angle 1, 53 degrees. Now, this was a quiz question that surprisingly stumped some of us. So we had a couple ways to think about it. Well, given angle 1 is 53 degrees, do we have enough information to get the 7 other angles? We do. Yeah, we do. So angle 1 is 53 degrees. Well, what must angle 2 be? What must angle 2? How much? Careful, angle 2. Why 127? Okay. In the end, Joey, you got it. Now, if we had said angle 3, then no, you would have been correct. Angle 3 and angle 1 is 53. Angle 1 and angle 2, they add up to 180. So that's the reason here. Angle 1 plus angle 2 must add up to equal 180 degrees. And that's how we get the 127. We have to do 180 minus 53. Now, given what we know here, can we get all the other angles at this point? Yeah. Well, an idea might be, think about, I know this is a bad hint, but I think I drew him bad. I'm sorry, Charles Schultz. Didn't mean that. Well, think of the Charlie Brown idea. You zigzag. That's one example. 1 and 3 are going to be congruent because they're vertical. 3 and 5 are going to be congruent because they're what type of angles? What type of angles are 3 and 5? Inside the parallel lines, and they're opposite. That means they have to be alternate interior. Or 1 and 5 are congruent because they're corresponding. So you have a couple of options here. And then, of course, 5 and 7. That's why I say think about the Charlie Brown idea, because you know how Charlie Brown is in the yellow shirt with the zigzag? Well, that's what we have going on here. We've got a little zigzag going on here. 1 to 3, down to 5, up to 7. And you can say the exact same thing for the other 3, 5, 7, 53 degrees. Then 2, 4, 6, 8, there you go. Anybody have any questions on problem 7A? So the key is this relationship between angle 1 and 2. You can say similar for angle 1 and 4. 53, 127, they're going to add up to 180. And then from there, you zigzag. That's the quickest way to knock this type of problem out. Now, 7B we will not do in class. I want you to try that at home. So 7B, the only thing we'll say about 7B, they gave you angle 8. So here's angle 8 right here. It's 135. Now you have to get the rest. Again, these lines are parallel. I will mark it so you know, okay, they're parallel lines. But you can get the remaining, try the remaining 7 on your own. We're not going to do that right now. All because I want us to save. I want us to do some other problems that we haven't seen in a while. Also, again, this review is a nice review for homework. Some of us have been given homework in on about our due dates, or before, some cases even before, and that's awesome. I might be giving back some work, but then there's some of us haven't turned in anything all quarter, and that's really going to affect your grade, and not in a good way. Okay, here we go. Number 8. I've seen these types of problems before. These ones, we're going to see them again. So given our diagram here, look where our two angles are. I'll highlight them. Give them the location of the two angles in question. Well, who could tell us what type of angles we have going on here? Who could tell us? So that's where they're marked. Let's have an idea on what type of angles we have here. Who'd like to take a guess? Not sure? No, you're right. They're alternate interior. Very good. It's 100% correct. If they're alternate interior, and see again, we have parallel lines because of those little triangles right here. The little triangles tell us these two lines are parallel. What do we know about the relationship between the 13x plus 9 and the 14x plus 2? Close. You're on the right track. Another word that begins with C. That's the word. They're going to be known. Alternate interior, congruent. That's because we're going to be dealing with parallel lines. Alternate interior, that means congruent. So what symbol are we going to put between the 13x plus 9 and the 14x plus 2? What symbol are we going to put between those two expressions? They're congruent. That means the two angles are equal. Boom, boom. There you go. They're going to equal each other. They equal. 13x plus 9 will equal to 14x plus 2. That's your equation setup. I want you all to really quick, give you all a minute or so to try to find a value of x. Now remember, x is on the opposite side. So you're going to have to do some moving around, but it's not as bad as it looks. I think you're going to find it in 2 steps. You need at most 2 steps to knock that problem out. So give you all a minute to do that. All right. Okay. Anybody find the value of x? What'd you get? We agree or disagree with 7? Agree? Anybody disagree or is anybody not sure? Better be honest. All right, you tell me you're not sure, but we can talk about it. So here's how we got the 7. Well, which x term do you want to move? The 13x or the 14x? Which one's going to be easy? Which one's the smaller one? 13. Move the 13x. All right. You have 9 equals. Well, what's 14x minus 13x? How many x's are going to be left? Just one x. And that's nice because do you really need the 1? No. That 1 disappears. And then last but not least, minus 2 on both sides. 7 will equal x, or x equals 7. Now, given x is 7, did anybody find the angle measurement? So it's not both. I should have put the s in parentheses. Because since they're both congruent, you only need 1. Anybody try to figure out what that angle measurement was? It says 100. Let's check. Take either one. What we're going to do, we'll probably put both real quick. You can do one or the other, whichever is easier for you. All right, so if we multiply 13 times 7, did anybody multiply 13 times 7? What would you get? 91? And if you add 9, what's 91 plus 9? Yup, 91. Now, if you did the same thing over here, 14 times 7, 98, add 2 more, what do you get? You also get 100. So that's why it wouldn't matter. If the angles are congruent, it's not going to matter which angle you pick. You're going to get the same number. Okay, anybody have any questions on that problem? All right. This next one, number 10. Look at our 2 angles here. You could tell us the relationship of those 2 angles. Given the location of those 2 angles, who could tell us what we have going on here? If you have to look through your notes, that's fine. What's that? Close. I'll give you the interior part. Consecutive interior. And the reason why it's consecutive interior is because they're on the same side of that transversal. Now, if they're consecutive interior, what's the relationship between the two angles? Subinterior, okay? Which means they add up to what number? 180. Yeah. Add up to 180. Therefore, our equation, 3x minus 5 plus 2x minus 15 equals 180.
Mister, why does it sound like this?
I'm sorry?
Why does it sound when you walk?
I don't know. All right, now, notice the x's are on the same side, along with the constants. So if they're all on the same side, do we combine the terms, or do we switch and move around? What should we do first? Who remembers? Combine the terms, or are we switching and moving first? So all four of these terms are on the same side of the equal sign. What do we need to do? Who remembers? Okay, who could tell us what our steps would be? Are we going to first subtract or add any terms, or are we combining like terms? What do we need to do here? Get all four of those terms, all on the same side of that equal sign. You will combine like terms. You have to combine the like terms. So that's CLT. Again, CLT, combine like terms. We'll do that. So if we combine our x's, 3x, 2x, join together, how many total x's? How many total x's will we have? With the nose. With those nose. With those nose. 3x and 2x's, how many x's in total?
Mister, what's the difference after that?
I said it earlier.
No, you didn't.
Cindy. I did. We'll deal with that later. Right now, let's deal with this problem. 3x and 2x. Combine them. How many x's do we have altogether? So let's pretend 3x is here. Now, oops. All right, that will not work. Then we have an X as a marker. 3 markers. And 2 more markers. How many markers do we have altogether? 5. That's all we're doing here. Now you have this other part. You have a -5, so you're buying something for $5. Now you're going to buy something else for another $15. How much money are you spending altogether? Or how much will you have to pay altogether? 20. Okay. From here, I want you all to try to solve for the x. Give you a moment or two. Okay. Anybody get a value of x? Anybody get that value of x? What'd you get? Huh? 40. All right, from here, x is 40. Anybody else get 40? You got that too, Norcus? Anybody else? Okay. Let's check if this is correct. That does sound like a good answer. Well, add 20 to both sides. Keep your 5x. What's 180 plus 20? That's 200. Divide by 5. Your x is 40. Now, do we need 1 or 2 angle measurements for this problem? We're going to need 2. They're not the same. Take your 3x minus 5. And it's not like the other problem. Two x minus 15. Put them in. So 3 times 40 is how much? And then minus 5. 120 minus 5 is 115. Okay, so that's one of them. Then the other angle. 2 times 40 minus 15. Now, if we add up 115 and 65, what should we get? 180. That's only the way to check. All right, questions on that problem? All right. Trying to look at which one's for next because I think for the next two, all we're going to talk about is just the relation, but you're going to try to solve them at home, or they might have been a skip till next time because I really want to start talking about like our slopes, lines, all that business before we walk out. Yeah, so this is more for our next time. Oh, I'm just going to tell you what the relationship is. So the relationship between these two angles will alternate exterior. There's your equation. You will try this on your own. We're on the next page. So yeah, alternate exterior, you set them equal. We'll go over that one next time. And similarly, this one is also going to be a next time. Now, who could tell us what's the relationship between these two angles? Who could take a guess? They're going to be congruent, but why will they be congruent? You're right, Noe. They're congruent. So you can set the 23x minus 5 equal to 21x plus 5. You can do that. That one's fine. But why would they be congruent? There's another reason. It also begins with the letter C. That's it, Joey. They're corresponding. They're congruent. Then it's there's your equation: 23x minus 5 equals 21x plus 5. All right. Come on, Dennis. Welcome back. So that's the relationship. You want to figure? I want you all to try that on your own. We'll talk about those problems on Thursday. Okay. Let's continue, please. We'll move on. This we've done more recently, the 4 types of slopes. Positive, negative, 0, and undefined. Kind of did these little diagrams to help us remember. Positive, negative, 0, undefined. So going forward, the next little activity, basically you would be matching. Which ones do we have? So, for instance, well, with the 0, which one out of the 4 is the 0 slope? Is it first, second, third, or fourth? Second. What about the negative slope? Which one is the negative slope? The first, third, or the fourth? Which one of these 3 remaining lines? So not the second one. Which one of the 3 remaining lines is the negative slope? Last one. And of course, positive slope. First one. then by process of elimination, undefined is this one. Okay, questions? And that will help us, especially when we start computing slopes, if we have an idea on what is what. Okay. Now, let's look at these real quick. For the first one, given that slant, what type of slope? Do we have a negative or a positive slope? Careful. It's going to be positive. Because, remember, when we start from this first point. How far? Well, first we have to figure out up and down. So for this first one, we're going from the point on the left to the point on the right. Are we going first up or down? We're going up. So how far up are we going? Careful, look at the points. We're just going from point to point. So how far up did we go? 1, 2, 3, 4. You went up 4. So it's up 4. And then what direction are we going? Right. How far? Go to the right 2 spots. So 4, right 2. So take our fraction. So in both cases, are both of these numbers going to be negative or positive? If we go up, is that positive or negative? Positive. You don't need the plus sign, but what about the right? Positive or negative? Going to the right is also positive. Now we have positive 4 over 2, or just 4 over 2. We don't need the signs in the end. What happens when we divide 4 divided by 2? What do we get? 4 divided by 2 is? Slope's going to be 2. And then the slope, remember they use the letter M for slope. So if you wrote it as M equals 2 or just 2, I'll give it to you for now. Now similarly, we're going to do this one. Start at this point here. We're going up or down first. How far down? Down 2. You went down 2. Is that positive or negative? Negative 2. Then did we go right or left? How far? So right 4. That is going right, positive or negative? Okay. So we have a negative 2 over positive 4. In the end, will our final answer be positive or negative? So you're dividing a positive into a negative. What's the overall final result going to be? It will be negative. Now, Can you simplify this fraction? 2 over 4. Can we simplify 2 over 4? Well, type in 2 divided by 4 in your calculator. What do you get? I know you're going to get a decimal. 0.5. Well, and then it would be negative. But what would be... So if we thought 0.5, regardless if it's positive or negative, what would be the smallest fraction? Like, smallest numbers, fraction-wise? 0.5. Huh? 1 over 2. In this case, it's going to be negative 1 over 2, but yeah. Negative 2 over 4 becomes negative 1 over 2. Good. So that would be our slope. Questions? Anybody have any questions? Okay. The next thing we're going to talk about, on the next slide, we're just going to do one of the two problems, not both. Because we'll do the other problem on Thursday. I know, today feels like a Monday. It's actually Tuesday. Still trying to get my days in check. All right. So anytime you're given 2 points, I promise you, you're going to get a question like this on your test. I'm guaranteeing it. So you may want to highlight this one. All right. Here's what we're going to do. I think we're going to do the first problem. And the second one's going to be a little different. But first one. Label your points. Now we just can't label them XY, XY. Because then we're going to get confused when we set up a formula. But I do tell everybody, make the first point x2, y2, and then make the second point x1, y1. Because then it's going to be easier for us when we use this formula. When we use our slope formula. Now, very important. This minus sign always stays. And especially when we do this first problem, you're going to see exactly why. The minus sign has to stay. When you do your substitution, what I tell everybody, put a minus sign. Put a minus sign. And it might be a little bit of extra work. Parentheses. Wait a second. Well, what's our y2 value? What number did we designate as y2? Negative 3. So you have negative 3 minus, what's our y1 value? Negative 5. And then we're going to talk about that in a second. Now, what about our x's? What's our x2 value? 0. And then what's x1? 6. Okay. Now, what really takes place when you have a minus negative? What operation is really happening? You're adding. So really, your numerator, you're adding -3 plus 5. So pretend you owe somebody $3. You have 5 in your hand. How much would you have left? You'd have $2. So in this case, -3 minus the -5, which became -3, plus 5 to the +2. What about the denominator? 0 minus 6. What's 0 minus 6 going to become? Is it positive or negative? Negative. Now, regardless, positive or negative, we're still going to be overall negative. Can you simplify that fraction 2/6? You can. Who can tell us what that new fraction will be? Perfect. -1/3. Some of you, if you put the sign, put that minus sign here. Oops, didn't want that. You put your minus sign either here, or if you put it in the middle, that's okay. Just don't put more than one minus sign. Because if you put an extra minus sign here, that's no good. You make that whole thing positive again. So you can put it either with the denominator or put it right in the middle. Okay, questions on number 3. Now, number 4, you would try on your own. But this one, and again, x2, y2, x1, y1. You can try that on your own, but that's going to be a special case. You can check it over later. That's a special case. Questions? All right. The other thing I wanted to do, let's see where we are. I know we have about, okay, no worries. Okay. All right. I'm just trying to think of what we need to cover. I want to cover some other things. All right, really quick. With 22, all you're doing, if you're given a graph, they tell you what this, you'd have to count the slope, and then this y-intercept point. Remember, that's your y-axis, x-axis. That just tells you the value of b. So x is 0, whatever your y value is, that's also your value of b. Don't worry so much about this problem. This one real quick I wanted to mention. Now, if we go from point to point, it doesn't matter where you start, which 2 points you use. Now, if we go from point to point, did we first go up and down between each point? Are you going up or down from getting from point to point?
Down.
Went down. Went down how far? Went down 4. And then did we go to the right or to the left? To the right, just 1. Now, if you go down, is that a positive or negative? Going down is -4. And then to the right, is that negative or positive?
Positive.
In this case, +1. So remember, it's down over right. Now, -4/1. What does -4/1 become? How do we simplify that fraction? What's anything divided by 1? Itself. So there's your slope. And then this y-intercept, basically, you just look where it crosses the y-axis. So this is your point, 0, -3, because we went down 1, 2, 3. This is your b value. Now, I don't know if I'm going to give you this particular problem. I might not. I'm going to see. But that's all you would need to do. Slope, and then ask yourself, where does that line cross the y-axis? If you have that, that's all you need. I do want to talk about setting up a couple linear equations. I think we have time for 1, maybe 2, and then we're gonna probably call it. So don't worry too much more about this problem. All right. So what's going to happen? What you would do, so we skipped a couple slides. I think we're just going to do one with like slope, point. Because remember, we did this a lot last week. So first, label everything. So you're in. 2, what's our x value? Who can tell us the x value? So on the next page. -3zx. And then what's our y value? Do we know the b value yet? No. So first solve for b. Or I should say next solve for b. First, label or list. And then next you solve. Because what's our... So you're going to replace. Replace the y with what number? What's our number for y?
1.
1 equals, what's our value for m? Is that m or is that x? M is, and then -3. Now, you would have gotten away with it in the end because these two numbers you multiply. So if you had put -3 times 2 by accident, you still would have been okay. Because then you have 1 equals, what's 2 times -3? -6. And then bring down a plus b. You got to be kidding. Okay? Huh? You might take it in case. I need to get in there. Right behind. Okay. Leave the calculators. All right, everybody come. Okay, we gotta go. Other way. Supposed to go the other way.
We go to sing?
Stinger 5 and 6. They're supposed to leave now?
Yeah, I think you go to Stinger 5. Yep.
Stinger 5, guys. So you want me to leave the